Thank you very much, Fanning. Yeah, it's such a pleasure to be here. We actually have been planning for this event for several years. And because of the pandemic, it just happened this year. And this year is bound to be special because this is the year why Microsoft Research Asia is celebrating our 25th anniversary. Of course, we understand that for prestigious university like the University of Tokyo, 25 years is actually nothing. I understand that in more than 3 years, you will be celebrating your 150th anniversary. We're actually very fortunate that right from the beginning, we have been partnering and collaborating with the University of Tokyo, and on multiple fronts. For example, over the last 20 years, we have been sponsoring and also initiating more than 200 collaborative research projects with the academia in Japan. More than 40% of those collaborative projects are with the University of Tokyo. We have also hosted more than 100 students and scholars from Japan. Again, more than 50% of those students and scholars have been from the University of Tokyo. And since 2002, we start giving out Microsoft Research Asia PhD fellowship. And the first fellowship winner from Japan is again from the University of Tokyo. And among the 31 fellows we were awarded in Japan, more than half of them, 16 of them, were students from the University of Tokyo. And as President Fujii mentioned, we signed the MOU between the University of Tokyo and also Microsoft. One of the focus areas is on diversity and inclusiveness. And just this June, we have also partnered with the Graduate School of Information Science and Technology in the University of Tokyo to have an ADA workshop to encourage students, and especially female students, to be more involved in computer science, research, and technology. We have also been extremely fortunate to be advised by many great professors from Japan. Many of them have been professors in the University of Tokyo. And in particular, Professor Kizuragawa has been serving on our technical advisory board since last year and has really been giving us excellent advice on how we should evolve our research and evolve our organization. And as we're celebrating our 25th anniversary, we're of course looking forward to the next 25 years. But in order to do so, we want to be grounded in the overall history of technical innovations. And we observe that every 30 to 50 years, there's going to be a new computing paradigm emerging. And the last time that happens is in 1973, where the first personal computer, Otto, was born in the Xerox PARC lab. And that just ushered a new generation, a new paradigm in computing technology around personal computing. Even today, 50 years after the creation of Otto, we're still more or less living in that paradigm. even though we have different form of computing, like smartphones. But all the concepts that were created then still prevail. And what about now? What we believe is that we're again at the zero spark moment of new computing paradigm. And that new computing paradigm is going to define computing for the coming decades. And as a research organization, we want to be at the forefront of that innovation. And this is why we believe that in the new paradigm, it really requires interdisciplinary research, research that will cross the boundary of a lot of domains that we work in now, in order to create breakthroughs that will lay the foundation for the new computing paradigm. And this actually shows how we're exploring and expanding the innovation frontiers. In the middle, there are a lot of traditional computer science research, but we are looking into opportunities to transform those areas. And imagine the future of a lot of those areas. And many of my colleagues will actually cover a lot of those topics. And in this talk, I will mainly focus on the two vertical bars, on the cross-disciplinary research, especially how it connects to not only science or computer science, but also to humanity and society. And to start, I'd like to invite my colleague, Dr. Dongshen Li, to talk about how he bridges brain science and machine learning. Let's welcome Dr. Dongshen Li on the stage.
Thank you, Li Dong. Good afternoon, everyone. My name is Dongshen Li from Microsoft Research Asia. Today, I'm going to talk about what will happen when machine learning meets the brain. First, let us take a look at brain signals. So this is a neuron. Once this neuron is activated, it will generate a spike. And this spike will be transmitted to other neurons connected to this one. Once a group of neurons fires together, they will form a local field potential. And this local field potential will propagate throughout our brain. So if we put an electrode on top of our scalp, we can collect a kind of a physiological signal called electroencephalogram, EEG for short. So EEG is one of the most important physiological signals for doctors to understand brain activities. For example, the delta wave will appear during our deep sleep. So alterations in delta wave may indicate sleep disorders. Also, patients with Parkinson's disease may also suffer from sleep disorder, so they may also have alterations in delta wave. There are a lot of existing work trying to use machine learning to understand EEG signals. However, most of the existing works trying to use one model for one task. For example, Model A can only be used for emotion recognition, and Model B can only be used for seizure detection. Different from existing works, we propose a new paradigm. We want to train one model for all the tasks. So we call it an EEG foundation model. It can take all kinds of EEG data as input and improve the performance of all EEG-related tasks. However, building such kind of EEG foundation model is very challenging. One of the major challenges comes from the data. In neuroscience research, researchers may use 62 channels of EEG data for emotion recognition. But in clinical practice, many doctors use 21 channels of EEG data for seizure detection. So actually, these two kinds of data sets may have different meanings, and we cannot simply combine them for model training. Now let me introduce how we address this gap. We know that we have brain functional regions in our brain, and each brain region is responsible for a kind of specific functionality, so that signals from the same functional area actually have similar meanings. Therefore, we propose to aggregate the signals from the same functional area to a hypernode. Then we can train the model in the level of hypernode instead of electrode. In this way, we can address the data gap. After the new data configuration, we propose an encoder-decoder architecture for self-supervised training. After this self-supervised training, we can significantly improve the performance of many EEG-related tasks. Now we have the EEG foundation model, based on which we can literally read our brain. By reading the brain, we can better detect brain anomaly. We can also decode brain signals. For example, we can decode what we see, what we hear, or even what we imagine from the EEG signals. Now first, let me introduce how we detect brain anomaly using this EEG foundation model. We propose a tool called AI Neurologist. So here is an EEG monitor. And we build a report generator. By a single click, it can generate a paragraph of text to describe this EEG example, just like a human neurologist do in clinical practice. We also provide an information retriever, which can retrieve relevant information to this example, so that doctors can better diagnose this example based on the retrieved data. We asked human neurologists to test the performance of this AI neurologist. And this is Dr. Hong from Ruijin Hospital. We asked her to do a neonate seizure detection task. Well, this task is very, very challenging. On average, human expert can only achieve 60% accuracy. Dr. Hong was very incredible. She can achieve 75% accuracy on this task. But our tool can make her even better. Her performance improved to 90% accuracy after using our tool. So this demonstrated that our tool can help to improve the performance of human neurologists. So many other collaborators from the hospitals are very positive to this tool. Now let me introduce how we use this EEG foundation model to decode brain signals. We propose a method called neuroimaging. It can be used to reconstruct human visual perception from the EEG signals. The method works like this. We first put an image in front of a person, and then we record the EEG signal of this person. We put the EEG signal into the foundation model, hoping to extract low-level image features, such as color and shape. And we also try to extract high-level semantic information of the image, such as the meaning of the image. Then we put both the low-level information and the high-level information into a pre-trained diffusion model, hoping to reconstruct the input image. So here are the experiments. These are the input images that we show to the person. And these are the low-level image features that we extracted from the EEG signals of the person. And these are the images generated by our method, we can see that we cannot exactly recover the same image that the person looked at, but the generated images are very semantically similar to the input ones. For example, the first row is a German Shepherd dog, and all our generated images are German Shepherd dogs. We also compare our method with a baseline method. We can see that the images generated by our method are much more realistic. We use an image classification model on those images. So this image classification model can only achieve 40% to 50% accuracy on the images generated by the baseline method. But this image classification model can achieve over 80% accuracy on the images generated by our method. So this is another evidence showing that the images generated by our method is much more realistic. Looking into the future, we would like to keep our interdisciplinary research between brain and AI, hoping to achieve stronger brain and stronger AI. Thank you.
Thank you so much, Dr. Dongshan Li. It's really amazing that now Dongshan has already demonstrated that AI can almost read our minds. But the most important thing is that with the research that Dongshan and others have been doing, we are able to understand the deep connection between brain science and AI that will actually help us advance both brain health and AI research. And this is the power of doing cross-disciplinary research. And it's not just science that we want to bridge into, but there are also many opportunities where we can do amazing things, to an understanding of humanity. So one example is about oracle bone restoration and curation. And this is one of the most ancient language systems that have been uncovered. But it's all inscribed on oracle bones. And one of the major challenges is to be able to decipher the 3,000 mysterious characters and see how they actually evolved from an ancient language system to the current language system. This turns out to be extremely challenging. And our researchers have been actually very curious about how the AI technology can actually help this challenging task. Because fundamentally, it's about language and image. And we have seen the great advances in AI on those two tasks. But it turns out the problem is not that simple. And in fact, after we connected with the experts in those domains, we realized that before we can tackle this problem, there's another fundamental problem that we have to solve. That is, there's a lot of inscription rubbings that have been created from those oracle bones. So no one actually directly worked on those oracle bones. They would look at all the inscription rubbing that's created, all the images that have been created. But because different people actually create different kind of images of the same oracle bone, it creates a lot of confusion. So one of the challenges is to actually connect those together. So our researchers actually have looked at and built a system called Diviner, which exactly accomplishes this task. It uses both image processing technologies and also deep neural network to find the invariant feature representations that exist across those images so that we can actually find, for example, you give me two images. Do we know that whether they are actually overlapping, whether they are from the inscription rubbing of the same oracle bone? Applying our system, you can find all these invariant connections. And this is the basis for us to be able to merge all the duplicates, detect the duplicates and merge them together so that we know that they're actually one piece. And now we have actually a more complete image of the underlying oracle bone. And that would be a major step forward for the research in that area, because now they're starting at a much higher ground. And you can do that actually not only between two images, but also on multiple images. And all those are actually real cases that our system actually detects. And all those connections have been actually validated manually by the Shang scholars that we've been working with. And that also shows the importance of working with domain experts in order for AI to be effective in solving those challenging problems. And in this case, all those three pieces can actually be put together into one. And that actually advances our understanding of this whole area very significantly. And because of this work, now more and more people are interested in decoding all those Asian scripts using AI technology. And there's actually a workshop being held. And in the future, there are just tremendous opportunities for us to understand a lot of Asian languages. And it's not just image processing. For another system from Westzhou, it's actually a 3D kind of structure where we have to stitch them together because there are a lot of tiny pieces and we don't know how they are connected together. And certainly AI can do a much, much better job than humans can manually using our own eyes. And I want to give you another example. This is actually a traditional computer science domain at the intersection of graphics, multimedia, and so on. And that is the idea of immersive communication. And so traditionally, we've been focusing on the communications among humans and want the communication to be immersive, and that's certainly very important. But what we believe, with the emergence of generative AI, the human AI communication will become dominant, will be increasingly important. And this is what we have been working on. And there are many scenarios. So we can imagine AI companions as our friends, as our tutor, or as our doctor. And you have seen the current interface of GPT-4, for example. It started mostly as text. So you have to really type your questions and you get answers. Of course, there are emotions being expressed in the language. But that's very minimal. That's not how we engage in conversations. And the recent release, of course, added audio. They can also detect image. So it's a much better experience. Now you can actually talk to GPT-4. But what we believe is we're going to create an even more immersive experience with some sort of persona. And from a research perspective, if you look at the traditional graphics research, right, we're talking a lot about 3D rendering. We're talking about in audio, we're talking about spatial audio that makes you feel that you're immersed in an environment that's being created. But we believe there's another dimension of immersiveness, and that's what we call emotional immersiveness. And that is a field that didn't exist before. And even the notion of emotion is not very well understood. So this is a particularly interesting research agenda that is actually beyond the traditional graphics, computer graphics. But we can start with computer graphics. And this is exactly how our researchers in the lab actually started working on this. What we want to create is this emotional responsive experience from an AI. that it can actually exhibit emotions like also exhibit empathy. And not just through natural language, but through face expressions and so on. And so in some sense, what we want AI to have is not just IQ, but also EQ. So we feel that we're actually engaging a conversation with an interesting real person. But it's very challenging. In computer graphics, there's this phenomenon called uncanny valley. Because our eyes are very good at detecting something that's not natural. So when you create something that's not natural, we will detect it. The experience will be poor. And our expressions are actually pretty rich. And there's a lot of micro expressions that our eyes can detect very easily. And there's also body language. When I talk, and you can sense, you can get a lot of signals implicitly. And all those signals are not even very well understood. And they're very nuanced. And if you describe the whole behavior, it's also continuous, continuous domain. So what we have done is to use deep learning technology and try to uncover this notion of emotion from a corpus of videos to capture what is the kind of emotion that we express. So I want to show you some examples from the current system. Those are very preliminary results. The way we generate this is that we first generate a voice input from our TTS system, text to speech, with some emotions built into it. And then we want to create this avatar. This is actually an AI-generated avatar that can speak with emotions that match with the voice input. So let's watch those videos.
Ha, that's so funny. How could you just not realize you got into the wrong room?
Remember, the input is just the voice. The voice contains this joyful kind of emotion, and all the facial expressions have been generated automatically.
Oh my God, are you kidding me? I can't believe this just happened. Oh, I'm so sorry to hear that. I hope your friend can recover soon and get back to us.
And you see that because of the different emotions embedded in the voice input, the facial expressions and so on are actually very different, and they look very realistic. And what's interesting is, when we started with traditional computer graphics or multimedia research, but it really is interdisciplinary research. We have to understand, learn from affective computing, try to understand emotions and sentiment. We can analyze them. And also there's deep psychological implications, how we can integrate the notion of empathy and really make sure that everything we do is human-centric. And finally, what's actually also important is when we build those capabilities, we want to make sure that it can be actually done safely and responsibly. And this is why we believe that it has deep connections with the notion of societal AI. And this is the dimension that also I want to emphasize here. That is, there's deep connections of all the research we do in AI to society. And on this topic, I'd like to invite my colleague, Dr. Xin Xie, to talk about their work on societal AI. Let's welcome Dr. Xin Xie.
Thanks, Lido. I'm Xin Xie from Microsoft Research Asia. Today, I'd like to share our recent exploration on how we can leverage social science insights and methodologies to tackle multifaceted challenges posed by AI. Throughout history, we have seen the evolution of social science and AI. They are both trying to understand human behavior and society. Let's take a brief walk through the history. From ancient times, we have seen the philosophical thinking of human behavior and human nature. And with time, a lot of different disciplines like psychology, like sociology, economics have been developed. And very recently, we see the integration of interdisciplinary and new methodologies have been applied to social science. And in parallel, in the past 70 years, we have seen the birth and rise of AI. Especially in the last few years, we start to see AI outperform human in a number of tasks. Although these two fields evolved separately, but we see the trend, they will converge and help each other. We believe that the convergence of social science and AI will equip us to understand and better prepare for what lies ahead. And here we use societal AI to represent an emerging discipline which studies the interplay of AI and human society. And we will study the culture, societal, and ethical impacts of integrating AI into the fabric of our daily lives. In this talk, I will briefly introduce how we can leverage social science insights to tackle AI challenges. Especially, we have collaboration with psychology, ethics, law, sociology, economics, and education. And we will use two examples to illustrate how we work together with them. One is evaluation, the other is alignment. In the past year, we have seen a lot of evaluation efforts have been invested to measure the performance of large language models. However, these evaluation methods have faced significant challenges. First, it's difficult for these evaluation methods to predict the potential of performance of models on tasks they have never seen or exposed to. Second, it's difficult to explain the difference of this performance across different models. And also, we have evaluated models, but we haven't evaluated these tests by themselves, how reliable they are. A lot of research and study have shown if we change the prompts, we change the questions, the performance will change significantly. So we need to make sure the quality of this evaluation themselves are high. When we look at the evaluation of a human, we see we actually face exactly the same challenges as assessing general purpose AI, as I mentioned, how we potential the performance of human, the future performance of human, how we explain this performance difference, and how we make sure this measurement is reliable. And the psychology researchers, they develop psychometrics to help this process by providing reliable measurement of human mental capacities and psychological attributes. So we try to work together with them to learn their experience and methodologies. So by working together with psychometric researchers in China and in Europe, we are working together to define this framework of evaluating general purpose AI with psychometrics. Different from AI evaluation, they start by defining what we need to measure. Usually they are construct, like value, abilities, and motivation. And then they will develop tests for this construct. In this way, they can improve the predictiveness, informativeness, and quality assurance. And this shows a high-level framework of how we do this. In general, there are 3 steps. The first step is we need to identify and clarify what we need to measure for AI models. So usually they could be called the latent construct of these models. And then after identify this model, these constructs, we should design the test scenarios and items and establish a scoring criteria. And very importantly, we still need to verify this measurement itself is reliable. So we could leverage some methodology from psychometrics to make sure this evaluation is reliable and valid. Since this is still ongoing, I think we will share more results in the future. And next, I will come to another challenge of AI, which is AI alignment. AI alignment, basically, these concepts may trace back to 80 years before, when the 3 laws of robotics have been proposed in scientific fictions. And later, a lot of philosophers have discussed and thinking around machine ethics. In the last 10 to 20 years, we have seen a lot of computer science and AI researchers have been working on alignment and value alignment. But in the last year, since the rapid development of big models, we have seen a lot of efforts have been turned to AI alignment and most recently super alignment. When we look at this research, we see a shift of the alignment goals. First, we help the AI models follow human instructions. And then later, we help them to respect our preference. And very recently, we try to integrate our own human values into these models and help they can have the same value as us. So we see this shift from human instruction to human value. The goal of alignment is changing. But there's still a lot of challenges on how we can integrate human values into AI. One of the challenges is even human, we are not able to define our values in a clear way. And also a lot of values we give to AI is not in a systematic or organized way. And many of them are changing according to different cultures and countries. So we also try to look into humanity and social science to find answers. We found that ethical researchers, they have studied basic human value. They try to simplify the behavior motivations into a few core principles. In this way, they can provide clarity, cultural adaptability, and transparency. So we plan to develop an AI alignment approach using basic values. So this figure just shows a framework of how we do this. First, we collect AI model behaviors, and using some basic value series, like Shiva's theory of basic human value, and we can identify the value in these AI model behaviors. And then we compare that with the target human value vectors, and using this difference as a reward to fine-tune the model to make sure it's aligned. So we call this basic value alignment. And in the long run, we have defined value compass, which is the goal is try to define a new paradigm for AI value alignment. We start with develop benchmark and value judgment model, and based on them, we plan to evaluate the value of different language models. And then we can verify these values by predict the future behavior or risks of these models. Eventually, we help to develop an efficient and adaptive alignment approach for these language models. So using these 2 examples, I hope you can understand how we collaborate with social science and what kind of convergence of AI and the social science will look like. And we believe that combining AI and social science will enhance our understanding of humanity and intelligence. And with that, I will give the stage back to Lido. Thank you. Thank you.
Yeah, I want to conclude that I hope we have established that AI is actually bringing down the barriers across many research disciplines. And it's creating the synergy with science and society. And it's time for us to adopt this cross-disciplinary research style and work together, especially work with everyone in the University of Tokyo to advance the state of art in science in a significant way and do it responsibly to benefit our society together. Thank you.